Welcome to the Dapr community call, April 20th. Thank you for joining. Thank you if you're watching this as a recorded community call on YouTube. Today, we have quite a few items. Here we go. We're going to be talking a little bit about the patches that we recently released after version 1.1. There's two patches, and we'll discuss what was exactly fixed in those. Both came from, these are issues that are in the release notes, but we feel like we want to go over them this call. We also, last week, if you've been following us on Twitter and on the blog, we kind of shared that there was a CodeCov security issue that was affecting us, and Aaron's going to cover how our maintainers went about to mitigate that and address all the vulnerabilities that were exposed there. We have a community member that was willing to show a demo of a cool app that he mentioned in our show and tell channel over Discord, which is, by the way, a great place to speak up if you have anything you want to show. I actually haven't seen Willem join the call, so I'm hoping he'll join by the time, so we'll have enough time to show it, but if not, then maybe we'll have to push it for the next call. And lastly, Yaron's going to give us some an overview of troubleshooting Dapr on Kubernetes. So with that, I think we'll get started. And Yaron, I believe you'll be covering the first item.
Yeah, let me share my screen. And let me know when you can see it.
Yeah, we see your screen.
Okay, so I'm going to talk about two patch releases that we did for Dapr. One is Dapr 1.1.1, and the other is Dapr 1.1.2, and explain why you should upgrade to those releases. So let's start off with Dapr 1.1.1. In the Dapr 1.1.0 release, we introduced a new feature for cron jobs, so that Dapr can actually be injected not only into Kubernetes deployments, but also into cron jobs. And cron jobs are operations that basically run to a finish. As part of that, there was a new API introduced called the shutdown API, which allows you to shut down the Dapr sidecar so that it can allow the job to run to completion. So the API there was a get endpoint, and we basically issued a patch release to change it to post for security reasons. And so if you're using the HTTP shutdown API directly in your app, which I don't think anyone would, but if you are, making use of that API for any reason, you should switch to using the post API. The get API is still there. We have a deprecation policy. It's going to be removed in the future. So currently it's deprecated, but you should really move to use the post HTTP API if and only if you're using this API from your application via HTTP. If you're using the SDKs, then you don't have an issue. If you're using gRPC, then you don't have any issue either. Only if you're using HTTP for the shutdown API for whatever reason inside of your application, only then you should upgrade to 1.1.1. 1.1.2. You should be upgrading to this release only if you're using the Azure Service Bus component for pub sub. We fixed a bunch of issues there where the PubSub component would throw issues that the connection has been closed when the upstream Azure Service Bus implementation would start throttling. So if you hit any throttling limits imposed by the service, the component itself would actually throw errors and would not recover. So there were a few metadata options for recovery that we added. So you might want to check docs for that. So if you go to the Dapr docs, just search for the Azure Service Bus component, and that issue has been mitigated by putting exponential backoff retry policies in place with configurable settings, like I said. Another thing we did was we discovered there was an extraneous API call being made with every publish request. So that basically made the problem worse because there was an additional API call that contributed to the throttling. So we removed that. And I also want to extend thanks to Phil Cady for the root cause analysis on this one, and to JovGeek79, whose name is Thomas, I think, if I'm not mistaken, and also to Charlie, who's not on this call, for looking into this matter and fixing it. So yeah, that's it. Back to you, Ori.
Yeah, if there are any questions or comments on this issue, please drop them in the chat. And as always, like that's true about anything. Phil, do you have anything you want to mention? Just as Yaron said, like you had a lot to do with kind of diving into this issue. I know we've also been talking with the Azure Service Bus SDK team, the SDK we're using in this component. Anything you want to add?
Not too much. I think the only thing I would say is I think we're going to make this even better, and I'll leave it at that.
Okay, great. That's great. Great to hear. So again, as Yaron mentioned, these patches are mostly recommended to people who are using those specific things, whether it's the shutdown API or the service bus component. Otherwise, I don't think there's really a need, an urgent need to move forward to that. If you have the version 1.1.0, you should be covered. Aaron, with that, I'll kind of let you speak to the CodeCov incident.
All right, cool. Thanks, Ori. Let me, just for a little context, I'll share my screen. I'm assuming you can find there.
Meanwhile, I will say that Yaron mentioned the service bus component reference. You'll note that that stuff, based on the previous call and some feedback we got, we moved all the component references to the reference section of the docs, which is something that actually Aaron did a lot to do. So thanks for that, Aaron. So it might be, yeah, you're showing it right now, great. So that is something that we got some feedback and we addressed.
I caught this morning that we forgot middleware, so I'm gonna go get that PR in as well, so we can move middleware component specs over here as well.
Yeah.
Yeah, so in terms of CodeCov, we started, what was it, last week, Thursday morning, with on the 15th, with CodeCov giving a notice that their bash uploader, which is used as part of their GitHub Actions, was compromised for a couple months until one of their customers alerted them that it was behaving suspiciously. So they learned on April 1st, they disclosed on April 15th. And we started that morning like reading through this, trying to understand it. It sounds like they identified a set of customers that were potentially impacted by this. And what this means is within our build pipeline, CodeCov handles code coverage for us. And as a GitHub action, it has access to all of the GitHub secrets. And so if you have a malicious GitHub Actions job or step, it will it could maliciously read all of those secrets and then send them back up to a malicious server. We didn't receive a notice from CodeCov that we were part of this impacted group. So we didn't have an indication that we were affected directly. However, in an overabundance of caution and following their guidance, we decided to go ahead and roll all of our GitHub secrets anyway. So we went through all of our repos. There were, I believe, 8 that had the CodeCov GitHub Actions step as part of their CI/CD pipelines. Went through, listed all of the secrets, mapped out which secrets went to our like package managers, which went to like code signing for the SDKs, which went to like our Docker hubs, to Azure and all of that. Thankfully, we kept decent notes on that. Anyway, once it was mapped out, keeping with, in a past life, for context, I was on a security team. So we then mapped out from top to bottom which secrets had access to what. So for example, Azure Service Principal passwords had access to the service principals, which in turn had access to the resource groups with all of our test infrastructure. So then we just cascaded down, replacing from the top down, taking into account any key vaults. We also ruled anything that was in an Azure Key Vault for our test infrastructure. And over the course of about 2 hours, we got everything rolled. So now every GitHub secret is completely refreshed, and we have a good process in place that we're going to actually continue going forward. And again, because with Dapr, we take security extremely seriously, both for the platform security on our build and release and our binary release and all of that, but also helping people build secure applications as well. So anyway, for more information, we did have a blog post that we wrote pretty much going through everything that I just covered. And if you want to learn more kind of how Dapr handles security, go to aka.ms/Dapr/security. And you can learn about how we do sidecar to app, sidecar to sidecar, and all the MTLS work, both for self-hosted and Kubernetes, and how we do network binding, state store management. We can actually take a look at our threat model that we created and had reviewed, and we do periodic security audits as well. And one thing we did as well is we went through and verified that all of our package managers and releases and everything were legitimate and matched up with our expected releases. So we verified the integrity of all our binaries. So all in all, this was about a 2 to 3 hour exercise in which we successfully rotated everything. Everything went as planned. And we keep a close eye on any sort of open source software that we use in our pipeline and the security state of those. So I think that's everything, unless I'm missing anything, Maureen.
Yeah, I think that's it. I think our big concern was, as you said, the integrity of our binaries and our builds. And we went to Docker Hub, we went to our release pipelines and checked that the binaries that are there are all part of release process that we kind of spun up or part of our official release cycles. I really want to thank the maintainers that were we kind of established basically like a war room. We just went all on a call, and thanks to Aaron, very meticulous kind of style and his, I guess, experience with security as well. We just went as a team, like one by one, and made sure to change everything. So this was Charlie and Mukundan. Charlie isn't on the call. Mukundan, I think, is also Hal and Phil. And your own, of course. We're on the call just war rooming this. So we take it very seriously. The minute we got notice of this, the same day, we just, like Aaron said, we kind of prioritized this, just sat on a call and just started rolling all the secrets. So I feel pretty good about the response. I feel to really affect the binaries and stuff, you have to be pretty sophisticated and really target us for that. It needs to be a very specific thing you had to do. That's not to say that you shouldn't address it, but I feel pretty sure that this incident, if it were exposed, it was only to a limited amount of time, and the risk is pretty low. And now that we've verified everything, I feel pretty good about it. So if you have any questions, even on this, I know there are some questions already on the chat being discussed. We can talk about them at the end, but if you have anything about this, again, feel free to drop it in the chat. Now, I'm not seeing, thank you, Aaron, unless there's anything else you want to add.
Thank you.
I'm not seeing that Willem is joined. He was supposed to show us a really cool app that he mentioned in the Show and Tell Discord channel. So I think we'll just skip it this time. If he joins, maybe by the end of the call, maybe we'll have an ability to show it. If not, maybe we'll skip it for another call. Jeroen, do you want to just go ahead and talk about troubleshooting Kubernetes now?
Yeah, sure. Just give me a sec here. All right, let me share my screen.
And we see it.
You can see it?
Yep.
Yep. All right. So this is actually going to be part one of of multiple parts for troubleshooting Dapr on Kubernetes. And then we might extend it to how to troubleshoot Dapr on VMs, which is a little bit more complex. So today I'm basically going to start off with the basics and show some common things that people run into and what to do when you encounter those issues. This is going to be part one. So this is a Kubernetes cluster that I have here. We can see that we don't have anything installed, nothing in the default namespace. Now, I don't know if you know the Dapr quick starts. So we have like a Python app and a Node app. And let's start off with by deploying the Node app, the Python app, which what it does is it tries to discover the Node app in the cluster and then just invoke it with Dapr service-to-service invocation. So normally what we do is we apply the component and the Node app and the Python app, but to simulate a failure case here, we're just going to apply the Python app here. And let's see how we can find out what's actually going on. So it's not going to find the Node app because the Node app is just not there. So yeah, not this. I think my path is actually here. So let's apply the Python app. And it's created, and let's put a watch here. So we can see that the pod's creating 1 from 2. So we have 2 containers here, right? One is our Python app and the other is the Dapr sidecar. And we can see that everything is running. Now, the Python code looks something like this. It's basically just a loop that takes a JSON message and then it calls into its local Dapr sidecar and says, hey, invoke the Node app on this method with this payload, but Node app is not there, right? So let's take a look at logs, and let's start off with our application logs and see what's happening. So we see that there are error messages, and we're getting error direct invoke. That's basically an error message that gets returned from the Dapr sidecar. And before we move on, this is a little known thing in its own right. So the reason why we see these logs is because in the code here, we're actually taking the response message and we're printing it. So not many people know, and maybe we should make that more apparent in our docs. But if you call Dapr and there's a failure of any kind, Dapr will return a status code and it'll return the error as the response text. So a lot of times if you want to see per call errors, just print out the exception. That'll help. So in this case, we see that we failed to invoke the Node app, but we don't really know why. The message here is pretty generic. It just says, hey, we failed to invoke the target app Node app after 3 retries. What do we do then, right? But what's happening? So normally you'd basically say, well, hey, let's look at the logs of the Dapr sidecar. Maybe that's gonna show us something. So let's do kubectl logs and take a look at the Dapr logs, and we see that there is nothing here. So we're still in the dark at this point. We don't see anything here. And what you want to do right now is basically change the Dapr sidecar app log level from info to debug. And the way to do that is to just go to your application YAML and add dapr.io/log level, then debug. Now, if you have the deployment YAML, that's all nice, and you can do that, and you can just go ahead and reapply this, and then it'll restart the pod with the desired log level. But a lot of times, you might be debugging an existing environment. You don't necessarily have access to the deployment YAML. You just know that you have a deployment in place. What do you do then? So a little known trick is that you can actually edit a deployment in place, right? So what we want to do is find the deployment. So let's do kubectl get deploy. And we see that it's called Python app. So now we can do kubectl edit deploy Python app. And we just open up the deployment in our local editor here. And if I see the annotations, I can just in place edit and add the desired annotation on the Kubernetes object itself. So instead of taking the deployment YAML template, which we might not have, I'm just adding the log level here. Okay, so I just added this and I'm going to exit. And if we look at the pods again, we can see that the container is restarting. Once this pod is going to run, this one's going to terminate. And now it's running again. So let's take a look at the app logs here. We can see that we're getting errors, but hopefully, if we look at the Dapr logs, we're going to see something a little bit more clear. And here it is. Now we're getting normal error messages. And now we can see that there is an unavailable message saying the target app is unavailable. And we get the actual error saying, hey, this error produced 0 addresses. So yes, our Node app is not there. And if you're running like an example hello world thing, it might be apparent that the app's not there. But if you're running in a production environment with dozens of services, maybe some of them are in other namespaces, which you might not even have access to check if the app's there, then those debug messages really come in handy there. Okay, so that's one thing that we have here. Let's delete this deployment. So I'm going to deploy the delete the Python app deploy, and now let's take a look at something else. This is our Node app here. We can see that the Node app is listening on port 3000, and in order to simulate the next failure, I'm just gonna crap out something here, and the app port is going to be changed to 3001. So let's go back here and apply the Node app. And this is going to simulate something that can happen for a few reasons, right? So what you're seeing here is that the Node app is running, but it's running only one of two containers. So we can see that the pod is not fully initialized and it seems to be stuck, but in a second, it'll probably start restarting, which is what we see here. So let's say you deployed your app and for some reason you see your pod just getting restarted for no obvious reason. And you, at this point, you don't even know if it's the Dapr sidecar fault or if it's your app. So how do we go about discovering? And as you can see, it'll just continue restarting here. So the first step you'd want to do on Kubernetes is to basically check whose fault is it, right? Is it Dapr's fault or is it our application fault? Because you're basically handling two containers here. So what you want to do here is basically describe the pod. So I'll just do kubectl describe pod, and I'll give it the pod name. And what you'll see here are the containers that are running. So we have the node container that's running. And if we look at its state, we can see that that's actually a running container. So that started off successfully. And we see that the Dapr container here is actually erroring out. So it is the container that has the restart count. And we can see that it has liveness and readiness probes. So the container is restarting because the deployment itself is just not healthy. Now, if you go here and you take the logs here, we can basically say, hey, we should be looking for something in the logs that will basically say, you know, for whatever reason, Dapr is not continuing with its init. So let's take a look at the logs. And we know that the Dapr sidecar is the faulty one here. So we're going to take a look at that. And we can see that we have the message here that's saying, waiting on port 3001. And we actually get this message saying this will block until the app is listening on that port. So what we can deduce is that the Dapr sidecar is waiting with its initialization until the app's running, but it's trying to contact it in the wrong port, which kicks in the readiness probes failing, and then the container is basically getting restarted. Now, the final type of failure that we're going to look at today is, and let me just delete this deployment too, so we can start from fresh slate. Okay. I'm going to change my app ID here to something that is invalid. And a lot of times you might apply your application and you don't actually see any pods getting created. And then you're really in the dark. And that also might occur because of a few reasons, right? So let's put an invalid app ID here and go back and reapply the Node app. And what we expect to see now is two containers running in a pod, but actually we don't. Like, this is the terminating pod from before, but we don't see anything that's running at the moment. So there is nothing actually running. And at this point, we don't even have anything to get logs from. So what do we do now? And so what you want to do in this case, if you don't see any pods appearing, it probably means that the sidecar injection failed. And the best place to look at that is to just do some deep Kubernetes debugging here. And you'll want to start off with the deployment. Okay, so you can see that the deployment has been created, but it has 0 pods out of a requested 1. And if you describe the deployment, you think you might see some useful information there, but you won't. Like, it only says, hey, I scaled up the replica node app to 1, which is kind of weird, right? Because it didn't actually scale it up. It just has a replica failure here, and it said fail to create. So on Kubernetes, every deployment is governed by an additional resource called a replica set. So in the case where you apply your app with Dapr and you don't see the Dapr sidecar, you want to immediately go into the replica set. So we can see that we have this replica set for our Node app, for the Dapr sidecar, and you actually want to describe that thing and not the deployment itself. So I'm just gonna describe the replica set. And if we look here, then you get the full error, and you can see that the Dapr sidecar injector was actually the one to deny the request. And the reason why is because we have an invalid app name, and it also gives you the name itself, and it'll scream out about which actual validation failed when you try to do that. Next, not in this talk, but in next sessions, we'll look at debugging the Kubernetes control plane, right? So in this case, the sidecar injector was at fault. The Kubernetes control plane, so far we've only dealt with the data plane, is basically deployed to the Dapr system namespace unless you've put in your own custom namespace. And for sidecar injections, or in cases where you apply your app and you don't see a sidecar, or just any pod in general, it's always the sidecar injector's fault. So you might look at the logs here, but there are some errors that won't get shown by the sidecar injector pod, right? So debugging the replica set, like I showed you here, that'll most times, like in the majority of cases, it'll give you the exact error that caused the pod not to be created. And that's the control plane pod that we want to look at here. The Dapr Sentry pod is the Dapr Certificate Authority pod. It comes into play only after pods are actually getting created. The placement pod is only if you're using actors. The operator pod only comes into play if you're using components, and it also kicks in after the Dapr sidecar has already been deployed. And the dashboard is an innocent, beautiful thing. It doesn't have anything to do with your deployments. So really the pods that you wanna keep an eye on are these 4 pods here. And the best way to see if your control plane is healthy is to use the Dapr CLI. We have a Dapr status -k command here, which will tell you the status and the health modes of all your Dapr components. So in the next community call meeting, we'll probably go into debugging the control plane and look at some more common issues for the data plane. That's it for this session. Back to you, Ori.
Thank you, Yaron. So I think now we'll just open it up for questions for people. I saw there was a bit of a discussion around some pub/sub features from Prakash. I think this was mostly addressed in the chat. I don't know, Phil, if you want to speak to that, or I can let you unmute Prakash if you want to speak to it as well.
That one I think is going to be interesting to solve for. And I think your recommendation of opening an issue where the community can discuss that one, we'd love to get some ideas, because it'll be a little tricky to implement some of those broker specific functions in. But I think we totally recognize like the ability to replay messages and things like that are essential. So
yeah, I know with the pub/sub model and the interfaces to external clients, right? We are targeting the lowest common denominator, and sometimes that may not work for everybody. So looks like we need to be, especially in the case of Kafka, I think this will help the community, right? So.
Yeah, I think we always try to. I think there's a consistent thing that anybody who ever worked in software knows about the balance of when you're trying to abstract something and generalize it. There's always that balance between how do I make it really kind of be able to really be generic, and on the other side really expose some more features. That's the kind of stuff we probably would be discussing in that issue and see what is the best course of action.
Yep, thank you.
Yeah, and I do want to emphasize again something we've been kind of communicating in the past few community calls, that the best way to signal, first of all, the best thing to do if you have any new proposals or issues is to open a GitHub issue. If it doesn't appear as a GitHub issue, it almost, you can say it doesn't exist for the purposes of the Dapr project. And moreover, if there are things that you feel that should be addressed in general, please upvote them. We started to look at that in terms of maintainers and things that we are considering to prioritize. Obviously, that's not the only parameter, but that definitely is kind of a way to get your voice and help us form the roadmap. One more thing I want to say is about PRs. We ever since we launched version 1.0, we've seen a really beautiful growth of PRs. I would put it this way, because we love to see more people jumping in and helping us build Dapr and make it better. With that, that means that our maintainers have more and more of things to go through. So we really appreciate the community's patience, because we really want to do the due diligence to make sure that the PRs that are coming in are in high quality, they don't break anything. Now that we're production ready and we have people building solutions with Dapr and putting them in production, we really want to stick by the support model and the certification process that we put in place for components to make sure we have a really high quality PRs. I do want to remind everybody that when you're putting a PR in a way, like it becomes part of Dapr, right? And then we all kind of own it, and we need to maintain it and sustain it. So even if it's a specific use case that is very relevant to you and is super important and critical, it might be so, but it still needs really careful attention to become part of Dapr, because it will be part of Dapr moving forward, hopefully forever and forever, and people will be able to build on that. So this is all to go to say that we might see like a little bit of a slowdown, but this is mostly because we really want to make sure that we do the due diligence. As we bring in more maintainers and more approvers, we're hoping to kind of scale that up. But please don't be frustrated if you're seeing that your PR is just hanging out. We do have just a lot of them that we go through. So that's something just to be aware of. I think I don't have exactly the numbers in front of me right now to show, but we have about like twice as many PRs coming from non-maintainers and approvers than we did like 4 months ago, which is a really big increase. As somebody who's a maintainer of the docs, we see that in the docs as well. I don't know, Yaron, if you have anything to say about that. I know you're a maintainer for the Dapr runtime, and you've been noticing this as well.
Yeah, all I want to say is keep the PRs coming. I mean,
yeah,
like that shouldn't discourage you.
Exactly.
If anything, it just means the community is growing. We're seeing more and more contributions, issues. That's great. Yeah, just Kubernetes, for example, it has, if I'm not mistaken, 1,100 PRs open like right now. And so things sometimes take years to get merged. So, for us, we hope that every PR is going to get merged within 30 days if tests pass and it's been reviewed. So just bear with us.
Yeah, exactly. Please don't be discouraged by what I said. Please keep the PRs coming. And we do have contributing guidance. And if you need more information about like conformance test or what you exactly need to do to make sure to speed this up, please feel free to reach out to maintainers or put those questions in the issues and PRs that you're opening. That of course will help us kind of move things along. I don't know if there's anything else. Unfortunately, again, I don't see Willem on the call, so we probably will not be doing the demo today. I see another question now. What is the timeline for making the Kafka pub subcomponent for Dapr GA? So we don't really have, feel free to jump in here, any of the maintainers, but we don't really have timelines for making specific components GA. There is this kind of threshold of requirements that we put in place in the docs. You can find that in the component section or around, we have I believe an article for component lifecycle or certification process. And it really is about just meeting this kind of threshold. And if you are able to contribute to that, that would definitely help speed it up. And if this is something that we see that people really are looking to do and looking to help with, then we can prioritize and help you get there. But we don't have a specific timeline right now, I don't believe. Okay, another question. Are there any plans on adding support for schema registry and other message formatting protobuf for Kafka pub subcomponent?
So what do you mean by message formatting? Because I mean, if you use the Dapr gRPC APIs, you basically send, you send byte arrays. Dapr doesn't really do any sort of deserialization on the data format on the wire. So that just gets transparently sent to Kafka.
So Rajesh, I think you can unmute now if you want to add to that.
Yeah, I'm exploring that. Haven't got it so far. We are using a JSON serialization. I'm planning to use the protobuf. So I see in your Kafka component, there was a certain thing that you need to set to say this is a message format I'm using. So I haven't explored, but I will explore and reach out to you. But I just wanted to get your opinion if it's a JSON format only, or is there other formats that it supports?
Okay. And if you have more specific questions, reach out on Discord. We can have chats there.
Yeah, sure. Yeah, thank you, Aaron.
Yeah, that's a good reminder. Any other questions and stuff beyond the call, always feel free to do on Discord. But we're still on the call, and we actually have some time. I don't know if there's any proposals or issues people want to discuss.
I see there was another question by Rajesh. Is it possible to add new Kafka topic subscriptions without requiring the sidecar restart? So not yet, but you will be able to do that in the future with declarative subscriptions. So I don't know if you know, in most of our examples, we show you how to subscribe to topics programmatically, but Dapr also has the ability to specify subscriptions via YAML, which you can apply. For example, if you're running on Kubernetes, you can apply them to the cluster. So currently, you need to restart the sidecar to pick up new subscriptions, but we are looking into hot reloading these. And so declarative subscriptions will be the way going forward to add new subscriptions without needing any restart of your application.
Okay, with that, I don't see anything else. So I think we might have oh, wait, there's something just came in. Looks like Dapr pub subcomponent published subscribe message from to message broker through REST calls. Will that affect performance? So
When Dapr uses PubSub, the Dapr sidecar uses whatever protocol the underlying message bus uses. Your app might use REST or gRPC to talk to Dapr. So yes, it will affect performance. I can tell you right now that at least with HTTP 1.1, when your app is calling Dapr, it will add 0.6 milliseconds to your latency. Other than that, the baseline is your app talking to the message bus, Dapr talking to the message bus. There isn't any added latency there. It's basically for PubSub, the added latency for your app calling into Dapr, which again is around 0.6 milliseconds.
And Yaron, correct me if I'm wrong, but for every component, it's kind of a case-by-case basis, right? We try to use the standard way to talk to that message broker. If it's like the service bus, then we use the official Azure SDK for that. So kind of a case-by-case basis.
Every component uses the most natural accepted Go driver for that specific message bus.
Okay, gonna give it another minute to see if anybody else has more questions.
Schema registry support, not at the moment. Can you open an issue on components contrib and we can take it from there? I mean, that might be something that's easy to add, so.
I think we can do that pretty simply, like I've done that in the
Yep.
past. There's
Yeah.
a lot of great Go libraries to support that. So
Yep, should be pretty simple. Yes, Love Oaks, yes. Well, when I say yes, sorry, I didn't read the or 6 milliseconds. No, it's 600 microseconds, not 6 milliseconds.
Yeah, very low latency additions. And we got some numbers in the docs for performance, at least for a service invocation. I don't know if actually this, I don't know if that includes the stuff for like PubSub and all that here on. Do we have numbers for that published or no?
No, so the reason, I mean, we will have those. The reason why we only have service invocation is because it's like a Dapr to Dapr communication. So there's
Right.
added latency there that we want to measure. Like for things like state stores and PubSub, it's very dependent on which component you're actually using. So because there is only one additional call here, when you're using a state store, message bus, or a binding, as opposed to 2 calls when doing service invocation, really the only thing you want to add is, you want to measure is the added latency when your app calls into Dapr, which is the same for every building block that Dapr has. And that's about 600 microseconds.
Okay.
Yes,
Yeah,
Phil, right on micro batching. That'll allow you to process a very large number of messages and will improve performance greatly. Yeah.
For PubSub, the call, we don't have a call between 2 Dapr sidecars. So the number might end up even being less than 0.6. Would that be right, Yara?
No. So that's what I said earlier. We don't have calls between 2 sidecars. For service-to-service invocation, our added latency is about 1.2 milliseconds.
Oh, so we did half that already. Okay.
Yeah, so it's half that because you don't have that call going in the middle.
Okay.
All right, so it looks like this is it.
Yeah, looks like this is it. Thank you for the questions. Thank you for attending. Please continue and if there's any additional questions or issues, GitHub and Discord are the place to raise those. Thanks again. Thank you to the presenters. And this again will be posted on YouTube, hopefully later today. If not, then tomorrow. And yeah, that's it. Hopefully see you next time in 2 weeks.